Good day everyone, welcome to our pre-calculus lesson this week. We will be talking about the circle. So what is a circle? Mathematically, it is defined as a set of all points on a plane that are equidistant from a fixed point on the plane called the center. The radius is the distance from the center to any point on the circle. Look at the figure. The circle has different parts: the chord, secant, tangent is the center, radius, and the diameter. So what is the standard form of the equation of the circle? Let P, xy be any point on the circle, and C, hk be the center of the circle, not on the origin, and R be the radius of the circle. To get the standard form of the equation of the circle, we will be applying the distance formula. In this case, the radius is the distance from the center to any point on the circle. So we will be expressing the distance formula as r equals square root of x minus h square plus y minus k square. So the equation of the circle in the standard form is x minus h square plus y minus k square equals r square. For example, number 1. Find the standard form of the equation of the circle whose center is at 2, 1 and whose radius is 2. So the first thing to do is to determine or write the given. The center is hk, which is 2, 1, and the radius is 2. Then proceed to the solution. Use our formula, x minus h square plus y minus 1 square. Use our formula, x minus h square plus y minus k square equals r square. In this case, it will become x minus 2 square plus y minus 1 square equals 2 square. So it will become x minus 2 square plus y minus 1 square equals 4. And that's the standard form of the equation of the circle, whose center is at 2, 1 and whose radius is 2. What is the general form of the equation of the circle? Since the standard form is x minus h square plus y minus k square equals r square, if you're going to expand this, you're going to arrive at ax square plus ay square plus dx plus ey plus f equals 0, where a is not equal to 0. So the general form of the equation of the circle is x square plus y square plus dx plus ey plus f equals 0. The constant a was divided in all the terms of the equation. That's why we arrive on that. D, E, and F are constants. Now example number 2. Express x minus 2 square plus y minus 1 square equals 4 into general form of the equation of the circle. Then graph the circle. This standard form is what we have obtained in item number 1. So now let's proceed to the solution. X minus 2 square plus y minus 1 square equals 4. Apply squaring of binomial. You will arrive at x square minus 4x plus 4 plus y square minus 2y plus 1 equals 4. Then write it as x square plus y square minus 4x minus 2y plus 4 plus 1 minus 4 equals 0. Combine the terms without variables. So you're going to arrive at x squared plus y squared minus 4x minus 2y plus 1. And that's the general form of the equation of the circle. You may use Symbolab, Mathway, or GeoGebra to graph the circle. As you can see here, or we type the equation in the standard form, and this is the graph of the circle. If we type the equation in general form, the same graph of the circle will appear. This shows that our answers are correct. Example number 3. Find the standard and general forms of the equation of the circle whose center is at negative 1, 1 and diameter is 4. Given the coordinate of the center, or the values of hk, which is negative 1, 1, remember that half of the diameter is the radius. So the length of the radius is 2. For the solution, substitute the values of h and k and r. You're going to have x plus 1 square plus y minus 1 square equals 2 square. So here, it is x minus negative 1. That's why it became x plus 1. Then the next line of your solution will become x plus 1 square plus y minus 1 square equals 4. And that's the standard form of the equation of the circle. To get the general form, first, apply squaring of binomial in x plus 1 square and y minus 1 square to get x squared plus 2x plus 1 plus y squared minus 2y plus 1 equals 4. Then write it into form x squared plus y squared plus 2x minus 2y plus 1 minus 4 equals 0. Combine the terms without the variables. So you're going to have x squared plus y squared plus 2x minus 2y minus 2 equals 0. And that's the general form of the equation of the circle. Example number 4. Find the standard and general form of the equation of the circle whose center is at the origin and the radius is 5. Since the radius is at the origin, the coordinate of the center is 0, 0, because the origin's coordinate is 0, 0. The length of the radius is 5, so r equals 5. For the solution, x minus 0 square plus y minus 0 square equals 5 square. So the standard form of the equation of the circle whose center is at the origin and radius is 5 is x squared plus y squared equals 25. So as you can see, it is very easy if the origin is at the center. And to get the general form, it just will become like this: x squared plus y squared minus 25 equals 0. That's the general form of the equation of the circle. Number 5. Find the standard form of the equation of the circle whose center is at negative 1, 0 and which passes through the point negative 1, negative 1. As you can see in this problem, the length of the radius is not given, but a certain point on the circle or on the circumference of the circle is given. We can say that negative 1, 0 and negative 1, negative 1 are the endpoints of a radius in that particular circle. So the distance between So the distance between these 2 points is the length of the radius of this circle. Here, we will be using the coordinate of the center, the point -1, -1, to find the length of the radius. For the solution, we will be using the distance formula. R equals square root of x minus h square plus y minus k square. So substitute the values of h and k and x and y. So we're going to have r equals square root of -1, -1, or -1 minus 1 square plus -1 minus 0 square. So it will become r equals square root of -2 square plus -1 square. It will become r equals square root of 4 plus 1. R equals square root of 5. So the length of the radius is square root of 5. And then substitute the value or the length of the radius to our standard form of the equation of the circle. Substitute also the coordinate of the center. So it will become x minus 1 square plus y minus 0 square equals square root of 5 square. So this will become x minus 1 square plus y square equals 5. And this is the standard form of the equation of the circle. Example number 6. Reduce x squared plus y squared minus 2x minus 10y plus 17 equals 0 to the standard form of the equation of the circle. As you can see, the given equation is in general form. So we will express this in standard form. For the solution, first write the given or the general form of the circle or the general form of the equation of the circle, and then transpose 17, so it will become x squared plus y squared minus 2x minus 10y equals -17. And then write the terms with x and with y beside with each other. So it will become x squared minus 2x plus y squared minus 10y equals -17. Then group it using parentheses. Then apply completing the square. Do you still remember how to complete a square? So here, x squared minus 2x, get the half of -2, which is -1, and then square it. The square of -1 is +1. That's why it became x squared minus 2x plus 1. Then applying completing the square, in y squared minus 10y, get the half of -10, which is -5, square -5, and that's +25. So the left side of our equation became x squared minus 2x plus 1 plus y squared minus 10y plus 25. Since we add 1 and 25 in the left side of the equation, by the principle of addition property of equality, we are going to add 1 and 25 also in the right side of the equation. That's why our solution will become x squared minus 2x plus 1 plus y squared minus 10y plus 25 equals -17 plus 1 plus 25. So continue solving. It will become x squared minus 2x plus 1 plus y squared minus 10y plus 25 equals 9. Because -17 plus 1 plus 25 will result to 9. And then, since this is a perfect square trinomial, we can express this as a square of a binomial. So it will become x minus 1 square plus x minus 5 square equals 9. And this is the standard form of the equation of the circle. Example number 7. Reduce x squared plus y squared minus 2x minus 4y plus 1 equals 0 to the standard form of the equation of a circle. Write the given equation, transpose 1. So it will become x squared plus y squared minus 2x minus 4y equals negative 1. And then write x squared and 2x and y squared minus 4y beside with each other. And then group the like terms inside the parentheses. Apply completing the square. So our solution will become like this. Again, to complete the square of x squared minus 2x, get the half of negative 2, which is negative 1, and then square negative 1, it will result to positive 1. For y squared minus 4y, half of negative 4 is negative 2, and the square of negative 2 is positive 4. Since we add 1 and 4 in the left side of the equation, by the principle of addition property of equality, we must also add 1 and 4 in the right side of the equation. So our solution will become x squared minus 2x plus 1 plus y squared minus 4y plus 4 equals negative 1 plus 1 plus 4. Next, this will be x squared minus 2x plus 1 plus y squared minus 4y plus 4 equals 4. Since x squared minus 2x plus 1 and y squared minus 4y plus 4 are perfect square trinomials, we can apply or we can express those as square of binomials or square of a binomial. So the result will become x squared minus 1 or x minus 1 square plus y minus 2 square equals 4. And this is the standard form of the equation of the circle. For practice exercises, kindly answer the following. Number 1, find the standard and general forms of the equation of the circle whose center is at negative 2, negative 1, and whose radius is 3. Then graph the circle. For number 2, find the standard and general forms of the equation of the circle whose center is at 3, 2, and which passes through the origin. Graph the circle. For number 3, reduce x squared plus y squared minus 6x plus 2y equals negative 10 to the standard form of the equation of a circle. For number 4, reduce x squared plus y squared plus 2x minus 4y plus 1 equals 0 to the standard form of the equation of a circle. So for challenger questions, number 1, find the standard and general forms of the equation of the circle with the center at 3, 1 and tangent to the line 4x plus 3y plus 5 equals 0. Number 2, find the standard and general forms of the equation of the circle with the center at the origin and tangent to the line 4x plus 3y equals 10. Last challenger question, find the standard and general forms of the equation of the circle whose diameter is the line segment joining negative 2, 2, and 2, negative 1. These are the hints in order for you to solve the challenger questions. Apply the formula for the directed distance from line to a point. The formula is r equals ax sub 1 plus by sub 1 plus c all over square root of a square plus b square. You will use it in challenger questions 1 and 2. Then for challenger question number 3, you will apply the midpoint formula to get the coordinate of the midpoint. X sub m equals x sub 1 plus x sub 2 all over 2. Then y sub m is equal to y sub 1 plus y sub 2 all over 2. Always remember that the only way to learn mathematics is to do mathematics. This is according to Paul Halmos. Thank you very much. I hope you learned something today. Keep safe and God bless you.